Hello, Pravin. How was the week?
The week was wonderful. The summer is here. The
That's
sun, as you
true.
can see, is
That's true.
shining. It's a lot of energy in the day.
Nice and bright. That is true. It's a bit windy, but it gets really warm. I
Yeah,
think
yeah.
yes, the good days are coming.
Oh yes, yes. I think yeah. I felt definitely felt way more energetic just because of the sun, and also I think it's now a lot of places. What I've noticed, everybody is expected to travel now.
Yeah, yeah, yeah,
So a lot of activity also is kind of moving around. I see a lot of people telling, "Hey, we can come visit." Be the company visit, site visits.
yeah.
So that is increasing. Kind of shows more liveliness in the city and in the work itself. It's like, oh yeah, we need to travel. We need to look good now. We can't
Yeah.
be just in our
Pajamas.
shorts. Yeah. Exactly.
That
Yeah.
is very true. I mean, even in the city now, for example, the commutes they have said that you don't need to wear mask anymore. It's not
Yeah.
compulsory, and
Even on the flights now, it has like there was a video that I saw in mid-flight to US. There was a pilot that I think the flight attendant came on, and then he announced that in the mid-flight he's like, okay, now no longer the masks are required. People are throwing their mask.
I mean,
It was.
it is definitely suffocating, and like
It
it's not
is.
the
Yeah.
best of experience sitting in
Yeah,
an airplane with
especially
the
if you
mask
if
on.
you have like a beard that is slightly harsher, even slightly harsher, it basically pokes into the mask and it kind of breaks those fibers, and those fibers is what you're inhaling. It's like
Yeah.
small. Yeah, yeah. You feel definitely suffocated. I think without beer, even like now those FFP2 masks that have come, they are way more comfortable.
Yeah.
But all those blue ones, I think they are made out of some cheap fabric
Yeah.
that kind of breaks down very easily.
I mean, they are like in a way like one-time use masks, but it just so
Yeah,
happens that like yeah, you will be like using and throwing so many masks, and your pockets are filled with masks, for example.
definitely. I think
Yeah.
yeah.
But anyway, I mean now hopefully like the mask time is yeah going away.
Yeah, except for China, I think there is where now Shanghai was closed. Now it's slightly start to open, but
Start
for
to
three
open, yeah,
weeks it was completely closed.
yeah, yeah.
Yeah, because of their
COVID policy, yeah.
zero COVID policy. Yeah,
Yeah, yeah. I mean, in India right now, it is increasing like a lot of new cases. But I think just that the repercussions of this particular COVID variation is not like in a way harmful in a way, in a deadly manner.
so
So
the death numbers are not that high, or
yeah, so,
hospitalization even are not that
yeah.
high.
I mean,
Yeah,
hospitalizations are increasing as I hear in Finland, but then the deaths is not. It's yeah.
yeah, yeah.
But yeah, anyway, I mean, which is why people are more relaxed.
But I
Yeah.
think yeah, I think to close the COVID topic is like now we just have to embrace and move on. Basically, that's how I see it. There's no way of getting rid of it.
Yeah, 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 yeah. So, well, that's on the COVID side. So, cool. So, what do you think? Should we also discuss, for example, what we wanted to discuss on our topic, which is blockchain?
Yeah, yeah. I think so. Blockchain, I think, as a topic, has been on everybody's mind because of all the freedom and fascination it allows. Be it with the financial system, be it for any other kind of anonymity, privacy reasons, and all that. Um, and because of the especially because of the new financing system, there have been a lot of unicorns in this area that have now come into play. So what especially I wanted to like dig into in blockchain is like what is the fundamentals of blockchain in a way that if you are the person who is just first time hearing about blockchain and is curious, how does this actually work and can I really trust it, and what makes it so, let's say, energy intensive, and just kind of broadening from there. So once your fundamentals are clear, then you can maybe jump into realizing, okay, what I can do with it.
Yeah.
where I can use it from very very fundamentals. Um, and the key fundamental thing in let's say, sorry, go ahead.
Quick question before we jump into the core. So for whoever would ever listen to us in the coming times to this video, why do you think we chose blockchain as a topic today? Like, what is our kind of motivation? Like, why blockchain? Why not some other technology?
Yeah, I think for some reason now there was recently a conference that was on Bitcoin and blockchains, and there have been, like, once again, a lot of people, especially hedge funds. So there was a time up till like about 10 years, there were still like very how do you say, small players putting their money in. But now, especially in US, the blockchain has crossed that threshold where now there are actually employment funds and insurance funds. They have their money in this technology, which is where the big money is. It's a huge amount of money, and there are special funds that are focused on it. And I think it has gotten to a point where it's too big to fail.
Yeah.
So, and if it goes to fail, there will be a bailouts and stuff like that. So, and now there are more regulations around it. So I think it's a time when you know that this is not some sort of fad that's gonna go away. And yeah, I think so. And this conference kind of was like the spark that, okay, like that's a very good topic to talk about in podcast. Yeah.
Yeah.
So it's I think it's called Bitcoin or something like that. That's the name of the conference, I think. Yeah.
Yeah, yeah, that's true. So basically, it is important that we and in general, like people out there, should uh, not just know the name like a fad blockchain, but kind of understand what this whole thing is about. And of
Yeah.
course, as they go about their lives, they can actually interact with it, make use of it, or at least understand it.
Yeah, I think also the key fundamental is that, let's say now you are giving away, let's say you get a salary of whatever, a certain percentage of it goes to your pension fund, and that pension fund is now considering investing into this.
Yeah.
So you are, by and not even choice, but are getting into this. So if you know, you might be able to, raise important questions like, okay, have you guys figured out that? You know,
Yeah.
because there are still open questions, and to be honest, the more you learn about it, the less you know.
Yeah.
and
Yeah.
and that's kind of the thing. And then, at least the open ends, that okay, here there are still doubts and things are not clear. So it
Yeah.
just helps you that where your money will go in your, yeah.
Actually, but even I have like a lot of questions. For example, when we talk about this application of pension funds. So
Yeah.
let's come, actually, we need to circle back there. Let's come there.
Yeah.
Let's maybe discuss now the technology and figure out
Yeah.
what are some of the things that we are not yet clear about, we don't know. And then we can talk about how these pension funds, such as applications, why they are in a way trusting, you know,
In
then
this, yeah.
this technology with all that kind of money.
Yeah. Yeah. So I think that's the fundamental of blockchain, or of this technology, is called basically hashing.
Yeah, yeah,
So hashing is basically given a set of data. Uh,
yeah,
Yeah, I think we have a word from our friend. He might not be able to join,
yeah,
but yeah, the so hashing is the function where you give it a set of data, and it generate a hash function for it. And
correct.
this data input can be like just zero letter, A B C D E, or you can have a gigabyte of file there.
Yeah,
Does not matter, but it will generate a fixed, kind of a fixed length. Let's
256
say you
bit.
say less than 30 characters of random string, and that's a hash function. So so this function, you input a data, and then it generates basically a string. And now, sorry, and in this, is you change any bit in this data, this hash function would change. And this is a fundamental block. And so it started kind of with NSA in USA. They developed the first ish, I would say, a function. It's called SHA1,
Yeah.
which is basically uh, so, and this is where the main problem is, I think, also, is that this hash functions, there is no mathematical model around it. It's basically, it's taking a set of data. Let's say we put uh, 1, 2, 3, 4 in
Yeah.
as an input. What it does, it basically converts, it takes that bits of 1, 2, 3, 4 characters, and then it basically does something. Okay, let's swap this bits here, let's multiply this bits here, and let's add this 2 bits here, and and then shorten this here, let me do this, and then throw out something. It's basically just, you say, okay, I take this, I just twist it around, cut it into pieces, put it like this, and that's it. um, but then there is like some sort of constraint. It's not, you can't be completely random like what you're doing. So there are kind of three basic rules that what you're not allowed to do. Like it, so if you have got a good hash function, you would know when it kind of meets these conditions. So given the y, I can't figure out the x. So basically, I gave an image or a 1, 2, 3, 4 string, and it produced a hash function, and it produced a hash of it. I put that hash back into this hash function, or something. And I cannot figure out what was the given thing was. I can't.
Yeah, yeah,
I
yeah.
cannot.
That is not yet. They don't know how to do it. No one knows how to do it.
No one
It
knows.
can't be
Yeah.
reversed engineer from that hash function to what
Yeah.
original message was.
Message was, and that's the key.
Yeah.
The first, and it's called like a pre-image like obstruction. So you want to stop it. So that's the first condition. So if you are a person who you want to make your own hash function, you would like test it like this. But yeah, I think that's the first thing. Then there is like a second condition, which is I think nobody like cares to follow because it's not very well defined. But then there is a third condition
But
which is
let's
very
talk about
critical.
the second one also.
Yeah. Second condition is like so it's you have a x, and you have a value, and then you have a sub of that value, and then you have hash and a sub of that hash, and they should also not match. You know, kind of. But it's so poorly defined that nobody actually can even check it. So that's why it's not worth to talk about it. They like, if somebody is checking hash function, they just skip the second step usually.
I see.
Yeah, it's very poorly defined. So it's like, it's a rule that is not well defined. You can't even follow it. So people just don't look into it. And the third one, which is the, I think, the most critical one, is to find collisions, which is like, so collisions are basically given a data input, it generates a hash. Okay. And then if I give uh, this value, I think, so let me try to define it well. So you're trying to figure out, for given x, I can find z, or the hash function, and then given that hash function, I can, so I use the same let's say hash function, and the hash that I got from it, if I input it, I can get it back the actual data.
Yeah.
So there is like, it's called collision,
Are you talking
where
about collision or proof of work?
it's not proof of work, it's
Okay.
collision.
Okay.
So this is just when you're trying to define the hash function. So this SHA-1 that I was talking about, that NSA developed. So let's say you input a string of 1, 2, 3, 4, and
Yeah.
it generated a hash.
Yeah.
And now you input this hash into your function, and it kind of gives out. So sorry, I think yeah. So this hash function um, have the similar hash with some other data. So you have 1, 2, 3, 4, and you have 4, 5, 6, 7, and both have kind of similar hash function. So that means these two data sets, even though they are different, they have same hash function. And that's a collision that has happened now, that you're not so you can't be certain which data was I referring to. So this is how you know very easily. So let's say it's very simple. So you start with, let's say, okay, the input data are numbers, okay, from 1 to whatever infinity, and there's a hash function that comes out of it, and you start to input 1, see hash function, you start to see 2, see hash function. And if your hash function if your hash repeats for any of these number, then there is a collision found. Then it's a bad hash function, because you can already see with numbers that there is this. It's very computer intensive to find this, because you're basically just running, every time and checking back. Okay, have I found this hash before? With and the input can be anything for hash functions. So that's the problem, because the input is infinite basically, and the output is finite, just the hash that comes out of it. So you basically are
Are you just a quick clarifying question? When you
yeah.
say a hash function output, are you talking about that binary digit that is the output of whatever input you give, which is unique to the input you provided?
It's not binary, but yeah, it's just a random string of words
Yeah, it's
and
not actually
hundreds.
binary.
Yeah,
You're right.
yeah,
Yeah, I'm
yeah,
wrong.
yeah,
Sorry. Uh,
yeah. I would say hash is the output. That is the ABC 1 2 3 whatever it
yeah, yeah,
is.
yeah, yeah, yeah.
The hash function is the thing that does the manipulation.
Yeah, and it will
Yeah,
change. Even if you
yeah,
change one item, digit,
yeah.
alphabet, like the whole hash function, basically, which I think is 256, right? Will
No, no.
change.
So yeah, so that the shard 256 is now the gold standard. That's
Yeah,
what also Bitcoin uses.
yeah,
But then, so SHA 256 is the one where this kind of the cycle. I take this number, I twist it, and I do this,
yeah,
and it's run 256 time. That's
yeah,
why so SHA-1 was just when it does it one time.
yeah.
You have 256 time. Is computationally intensive, but still, you can do it pretty fast. And then once you do it this way, you can be certain that for my input, this is the unique hash that I'm getting. With collision, what we are trying to figure out, that for the two other different type of inputs, so I have one here a different input and here different input, but it generates the same hash function. So with SHA-1, you can very easily find this collision. So for two different messages, it would generate same, the hash. So then you're like, okay, this hash function, the SHA-1 is not good, because I can find collision. That means it's not secure. So yeah, it's not unique. So this is the fundamental block. So SHA, no, not SHA, but just the hash function, any type of hash function that you find. You just have to make sure it follows this, mainly the two conditions. So the first one was that given the hash, I cannot figure out what was the input message for it.
Which is anyway the
And
case. Yeah,
yeah, that's easier to achieve. And then the second one is to mainly to avoid the collision. So for two different inputs, it cannot have the same hash output.
yeah, yeah.
So yeah, it should not. But not every hash function has it, and there is no mathematical proof that you can do for it. That's the problem. So we just have to run billions of and check back if it matches, and if it doesn't, then basically you're kind of like sure that, okay, I've run it enough time that I'm sure that it doesn't have that
Ah,
collision.
interesting, interesting. I think you went deeper into how the hash function
Yeah,
output is actually generated.
yeah, yeah,
Like in my kind of reading, the thing that I could grab is that people don't actually even know how that number, kind of that unique sequence of alpha digit code is even
So
generated.
no, so you can actually open and read SHA-256. It's not like a black box. You know what it is doing. But the thing is that given that there is no mathematical, like how, in physics, you can write a mathematical formula for certain thing and say, okay, I can prove it. Given this, I can prove that. Uh, and that there will be, up, you can try up to infinity and there will not be any collision occurring, like analytically. But you can't prove it. You just have to run it.
You have to
Uh,
run it and test it.
yeah, but if you think about it, the most fundamental block of where we are trying to rest our economy is a known black box. That was for me very fascinating. I was like, okay, people don't know, they are not sure, but they believe
But
this SHA-256 is well tested now. It's been now, let's say, over Bitcoin, it has been running and stuff like that. So we had not found collision.
and
So we, yeah,
and basically when we talk about like this collision, right, and we like, let's talk about like SHA-256, which is
yeah,
basically and correct me of course, is basically the output has the possibilities of 2 raised to the power 256. There are so many unique basically sequence of alpha digit codes that can be produced, and this
yes.
number is so large, this number is so
Mhm.
large that it is even impossible to kind of replicate.
It's so once you say impossible, so you have to be very mathematical how you say this thing. So in this case, I would like just rephrase it. So unless you can't prove it otherwise, so you have to prove very definitively that there will not be similar hash function for different messages.
So
So that's
it's really
so
good that you pointed out. I saw this one video by three blue one brown.
yeah,
He actually did a mathematical calculation of 2 raised to power 256, and it's crazy. It's he and I mean obviously it's just a 5-minute video that he made,
yes,
but
yes, it's a
this
wonderful
number is so
explainer video.
big
Yeah,
that even if you take the complete Milky Way, and in the whole Milky Way there are thousands of Earths. In those thousands of Earths, if half the population have GPUs that even Google right now does not have,
yeah.
multiply that by 1,000. Still, there is like one more Milky Way you can add to it, and still not receive the possibilities of
Yeah,
256.
yeah, and I think once again that is maybe talking about the pre-image that is like given the output you cannot figure out what was the input. Uh,
It is actually talking about the actual this one. What you say, the SHA 256
yeah,
output? How many there
yeah,
are?
yeah. There are so many output, but then like there is no mathematical proof that it will not collide. So
Yeah, that is true. That is true. Like, that is true. I don't think
yeah,
that
and
point is addressed. Yeah.
yeah, I don't think that's the thing I've noticed. So if you go to, so what I did basically, I did this complete course on. They have Stanford and MIT also. They have the about the whole thing, and that's where I think they get into the weeds, and you really get to see, okay, where there are missing bits now. Like, and in this case, there is you will get a Fields Medal, which is like the mathematics of like Nobel Prize, if you can prove mathematically that this function has something that it will not collide. So given a message of 1 2 3 4 and 5 6 7 8, or whatever other thing is, it will have a different hash function for both of those.
Yeah.
Um,
Yeah.
and it's crazy. I know, but then the main thing is the yeah.
So, let's take a step back, because I think talking like talking about this, we went into the weeds. Yeah, we
Yeah,
went
yeah,
really really deep. So let's take a step back. So we have basically SHA 256, which we at a high level just we can say that it is an output to an input of a data, and the
yeah,
output is so unique that we can for now say that it is it just never overlaps with any other output.
Yeah, yeah.
And that is the
So,
whole idea behind.
yeah, so
Yeah,
that's the first assumption that we have to keep in mind,
yeah,
that it's
exactly,
all
exactly,
relying on this hash function,
exactly. So
and
that's
its reliability of, not
the
being
whole
able to
system,
cross.
the whole
Yeah,
block. Yeah,
yeah, the whole blockchain.
yeah,
So now, there are, so to blockchain, it's once again, it's a very, in this, I think one of the things that we can mention, that, like, any given data, if you change anything, the hash function changes, and all that. So, so the hash changes, not the hash function. The hash changes. So even if somebody tampers with your given data, it will have a different hash. So the blockchain is, then now you have made a hash function. Let's say you can do it on your computer. You can call this hash function, write a message. Uh, let's say weather is great today, and you can call this function on your, like, Windows PC or Mac as well, and then it will give you a string of hash. And then, uh, now, from here, how the blockchain works, and I think that's, like, the steps. I think it's very good to know. So you want to create, so what blockchain is basically a ledger of data. So let's say Rahul Bhai had 1,000 euros, and he now want to give, to start with, you just start with, okay, Rahul Bhai has 1,000 euros, he is rich, and he started the blockchain. But, and then he does the first transaction to, whosoever he wants to give. So he's defined this. He can define new participant and give them money, and then that's the next block that got added. And then there is the, uh, let's say somebody else joins in, and then you want to give them money, and that's how you have these blocks. And in this first block of information, where Rahul Bhai has X amount of coins, or whatever, uh, jumping from here, the data input is basically the list Rahul Bhai 1,000, and that's the thing, that's the data in input into the hash function, and it generated a hash. It is, this hash is not pointing to anywhere else. And then as you jump onto the next block, where Rahul Bhai is giving the transaction, Rahul Bhai is giving to Pravin 500. Okay, now in the list it says Rahul Bhai minus 500, Pravin plus 500. Okay, so now that is the data input, and now there is the hash for that block generated, and it refers to the previous hash of the block that was saying just Rahul Bhai is equal to 1,000. So Rahul Bhai has 1,000. So, and this sequence, so that there is the it adds the previous hash, and including the previous hash and the new message, that is Rahul Bhai minus 500, Pravin plus 500, and the previous hash makes a new hash function. And then you keep doing it, and that's the
yeah.
basic blockchain.
Yeah,
uh,
if I just kind of add to it, so basically what you explained from Rahul Bhai, 1,000 euros, put it on a ledger. I will just like take a step back, like just talking from like a slightly historical and use case point of view, like why we even have this, why to create a blockchain in the first place. So basically, what I understood is like whenever there's a transaction, it is put in a notebook. That
yes,
notebook is a ledger.
it's a ledger. Yeah.
Currently, banks manage that ledger.
Yes.
And they are the ones telling you how I manage my book. These are the rules. And I am the one who is responsible for managing the book. Now, you
Yeah.
don't know what they are doing. They are a
No.
single entity, they can do anything. It's like saying who watches the watchman, you know. It's like that. So
Yeah.
basically, so the concept here is this: me, you said like whatever we are transacting, interacting, and kind of transferring funds to each other. We have this notebook, and what is unique about this notebook is all three or four of us will have the same basically updated copy of the notebook. So obviously it's a digital version, and there is two aspects to it. There's a private key and a public key. So the private key is unique to us, which we obviously don't share. And then there is a public key. So the idea is that when the public key and the private key together meets, then we are able to make any changes to it. But when I make any changes to it, then it is simultaneously reflecting in everyone's ledger. And now how this happens is what the whole concept is about. How did it get like updated everywhere, and why should I trust it to begin with?
Yeah. So I think in the process of just like adding that information, I think you introduced new concepts there. So I did not talk about distributed blockchains. So it's mostly from hash function to blockchain.
Yeah.
Then I think the introduction of like money as a thing to just we don't want to trust any single authority. We
Yeah.
don't know what they're doing, so we want to be kind of decentralized. So to make it decentralized, you have to have distributed kind of networks where there is no single authority, but almost everybody is an authority, and they are making sure that whatever is happening is according to the certain rules that are mathematically defined. Nobody can play with them. So there is one thing is the distributed maintaining distributed databases kind of. So you have to make sure that the timing and which blocks get added and all. So there is one technology there. Then the second technology that you talked about is signature, which is like the private key, public key,
Yeah. Yeah.
which is very key as a concept.
Yeah.
So I think the idea got generated for this one is in through the email. So how do you know if I sent you an email?
Yeah.
So there was in a very early version, even before Gmail, Yahoo, or any of these emails, there was the kind of a distributed email type of a system where I could send you an email and you would know because that has my public and this private key. So that's how that whole idea. And these hash functions were there back then as well. They were just using very simpler form of it, like just the SHA. I think there is a MD5 one, which was made for emails, which is very unsafe, but still, like it was for back then, it was quite good. So you could directly send a mail to somebody, and this was created, and the signature concept comes from there for why you should have a public key, and it's very easy to create this signature function. And I think nowadays we use it like DocuSign and all that. It just are basically evolved version of that. And I think there was one more thing that is the you have the decentralization, and then you
It's
have
proof
the
of
so
work.
that's yeah, yeah. I think proof of work. I think that's the next bit that um, so before blockchain, there were sorry, before the Bitcoin blockchain, there were a lot of attempts even before that to it's such a big problem to have trust centralized banks and all that. And the main thing, so there are two key differences why blockchain with Bitcoin became such a success. And I think if we go into that's a, but it's very simple thing. So before Bitcoin blockchain, everything relied on identity. So you
Yeah.
have to like kind of have a KYC of the person who's joining your network. Like nowadays, also if you go to a website, they want your identity. But the fundamental like idea of blockchain was like, okay, it doesn't matter who you are. You're just a
Yeah.
hash of whatever, and you will be just you can have your this like signature, and then you can sign from wherever you are. You just have to have this private key. It does not we don't need any like name or whatever for this. So overall, that's the first thing. So let's say you are not changing your email, you're not changing your phone number, so you're not trusting anybody, you're not trusting anything, you're just trusting that this private key that I hold is the thing. And that was the very big innovation that actually made Bitcoin blockchain what it is, because the previous blockchains they tried to have it identity based, and that's the big change. And the second thing is definitely the gas thing, that as you were trying out by the proof of work bit,
Yeah.
which which is basically, now, because you have given anybody an option to join this, they can just start adding blocks to it. So what is stopping them? And the mechanism to do that, and then we get into the weeds of proof of work.
Yeah.
It's kind of like there is a cost associated with adding a new block.
And just to kind of quickly maybe do a definition here, a block is a transaction.
A
So
block is a
so
transaction,
yeah, like for
but
people
it
might
can be
be
anything. So let's say
or a
now in
change.
the,
Yeah.
yeah, it can be anything. And so if you just talk in terms of like currency, it can be just this ledger. In case of if we go into Ethereum, it's actually a code. It's a code that gets executed. So let's say we started this decentralized organization, DAOs, that is how it's called, and we say, okay, Rahul Bhai owns 100% of the company. Now this 100% cannot change. So that's the rule, and you have written a small code in there. It says company ownership maximum 100%, and it cannot exceed that. So, and then anytime, then the rule is basically the ownership percentage, 51% ownership can agree, and if that much ownership agrees, the decision of the change in the organization happens. So you can have also like actually small codes in there, so nobody can change the code. You can see it. Everybody can see the code of how the organization's rule will be. And then you have the ownership. So as you have, let's say, ownership of 51%, you can have the capability to change it as a company. So you have also, so but keep it simple, I think we can just focus on ledgers of like transaction that is more easily understandable in the way of, okay, I'm giving you money, I want more money, and all that. Yeah.
Yeah. So, maybe just kind of continuing on this concept of blockchain. Yeah. And a chain is basically, for example, added whenever basically a certain change is made to a ledger.
Yeah.
That
Yeah.
change could be updating a transaction or a new transaction. Now
Yeah.
there's a block. Now
Yeah.
the interesting thing is, and this is the kind of the proof of work thing that also you mentioned and I mentioned, is that why should I trust? Like tomorrow there can be like a, in our group there is a new person that joins, and now that new person that joins can make any kind of edits to our ledger because we
Yeah.
all have the same copy. Now, how
Yeah.
do we kind of make sure that that does not happen, that we don't get cheated here? So, yeah.
Yeah. Yeah. So I think to be able to add a block, the proof of work, which is everybody hates in the community about like is that it's a mathematically difficult problem that is created by the Bitcoin blockchain, that if in order to add a new block, you need to be able to solve this huge mathematical problem. And it is defined in a way that the difficulty level increases
Yeah.
with every blocks that gets added. So people who were adding initial blocks, they could do solve it very easily.
Yeah. I
But
mean,
as
the
the
idea is
chain,
that the more miners join, the more difficult it gets. That
yeah.
is the basic
So
idea.
yeah. So the more participant it is, the more difficult it is to change, and it's very
It,
good logic in a
it
way that,
actually, I really
okay,
like the logic. I see why the miners would hate it because that is the, like, if we talk about the real core where energy is consumed, it is that.
yeah, I think, and this is where it gets to the point, like when so you have assets, and those are very difficult to move. There are different, like you have home, it's very difficult to move, and then you have money, that is like cash, that's very easy to move. That's a function of money. So Bitcoin actually, because of this proof of work, has become an asset rather than a currency. So you can
But
see,
currency, proof of work is not the currency. Proof of
Proof of
work
work
is
is
the
not the
asset.
currency,
Yeah,
but
yeah, yeah.
what proof of works makes it is it makes it
Yeah.
actually,
You get the
yeah, it makes
currency
it an
because
asset.
of that. Yeah.
Yeah, yeah. So it started as like, okay, Bitcoin can be the currency, but it actually now became an asset that you just can hold. It's like a company, or something like that, or a gold, or whatever. So proof of work is so difficult that to add any change to it is very expensive.
Yeah.
So so if I hold the asset, I have the ability to, like, it will appreciate, because it's just going to get difficult. So you hold the asset because it's going to appreciate, and I think that's proof of works makes it. But
You know,
yeah,
I would kind of keep this concept of asset, which is Bitcoin as an asset, and the functioning, which is proof of work, I kind of in two different boxes.
they are separate
They're
things. They're
different
definitely. But
because
what I'm
whatever
saying, like,
value
one is
bit,
the
yeah,
another consequence of another. So it's like the
one
because
is, yeah,
Bitcoin uses proof of work to add new block. uh, the uh, the gas or the change currency is becoming an asset. It's
yeah,
kind
yeah,
of,
yeah. I
yeah.
mean, asset is just an outcome.
Asset
It's
is
just an
just an
outcome. You
outcome.
know, it's
Yeah,
like,
it's
okay, we
just an
did a
outcome.
lot of valuable work and we are getting whatever we are getting. That is Bitcoin. So
Yeah,
there is no control over it. Something is popular, something is not. But this
yeah,
concept of proof of work is very, very amazing. Because, for example, we have a ledger. Okay. In this ledger, now there is a condition that the end of the ledger would be a code. That code is proof of work. How that code is made, which takes a lot of engine, like power, horsepower, like computational
computing
power,
power. Yeah,
is that, for example, in my ledger I can have a condition that in my 256 basically alphanumeric code, for example, the first 30 digits will be zero. Okay, it could be the first 60. It's like what if the decision is made on some things, we don't need to kind of go there.
yeah,
Now, because your content of the ledger is unique, to find out that proof of work code that will lead to 30 zeros out of that 256, it's
yeah.
very, very intensive and it's complete hit and trial. You actually have to start from 1, 2, 3, 4, 2 million, 3 million, like that.
Exactly. And now here comes the bit, like, now, the helping of fundamentals. So you are running basically that SHA-256 that we
Yeah,
talked about
yeah, yeah,
all the time.
yeah.
And there is no way to figure it out the backward. That's why you just have to run it forward.
Y-
And then the rule, as you said, that proof of work adds, like in Bitcoin, I think it's the initial four, it should be zeros. So there should be like four zeros. So the hash function should begin with four zeros.
Yeah, yeah. So for example, this
No hash, yeah.
SHA-256 outcome is a result of the proof of work code. So like you said, you cannot backtrack it. You always have to go forward, which is
Yes.
you just have to play with these your ledger end of the ledger code. And whatever that code is, we don't know, but when it results to 30 zeros, 31st zeros, you know that now this proof of work can go to the next block. It can go to the
Yeah.
next block. And whoever has arrived with this proof of work number earns a Bitcoin for the very hard work that they just did,
That they have done.
that
Yeah.
they have
Yeah.
done. And then we have a blockchain just like that. And
Yeah.
if you change
Yeah.
any digit in one ledger, this proof of work number that you figured out with so much blood and sweat and energy,
It's gone.
you have to figure it out again.
Yeah.
And that's the whole game.
Yeah. But like, as you see, like this rule of proof of work, it's kind of silly, because I just put up this. Okay, it needs to have four zero. It doesn't have to. you know, it doesn't have to make that transaction happen. It doesn't have to have. But I have added this complexity, and I'm not using this computing power to figure out anything important. I'm
But the
just
thing
using
is
it to,
this is the trust in the system.
yeah,
Because you can add anything now to the ledger. You can add anything. So how do we even protect it?
yeah. It is so true. I think definitely this is what makes it so secure and immutable, that if anybody want to make any change anywhere, they have to spend, like in Bitcoins, and they have to spend so much of computing power. It's not only Bitcoins, they have to just have an immense amount of computing power.
So, the thing is that, for example, if mine or your company would like to use basically blockchain as a way to make sure that the raw material we purchased in other part of the world is what we are receiving here in quantity, quality, and all those kind of metadata.
Mm-hmm.
It's a very straightforward thing, basically, because we are not creating our blockchain. The miners are basically listening to, collecting all the basically blocks, creating the chain, and we are trusting their work for which they are getting paid in Bitcoin.
Yeah.
Okay, so we don't have to do anything, we have to pay. But the miners basically are doing all the work, who have to make sure that they're collecting the ledger from everyone, and they have to make sure that the proof of work is connected from one block to the next block.
Yeah.
And once they have done that, then communicate to people like me and you and say, you know what, your ledger is correct, and now I can just make the payment to the supplier.
Yeah. Yeah. Yeah, yeah, I think that is definitely, I think, the most powerful use case. Like, so I think let's just kind of track back a bit to my just. So we started with the hash functions, then we jumped into understanding blockchain, like what is the
The bit of
block.
historical context, yeah,
Yeah, block, and then yeah, like why the
why it's needed, yeah.
yeah, why it's needed, and then we got into like, okay, what is a blockchain, and then we got into the what did we go into it next, Albert?
After that, we went to proof of work.
Yeah, proof of work. Now, I think I took a tangent there just to explain like distributed, and then there was one more thing, but yeah, I think it
No,
was
after the historical, we went into currency, distributor, and
yeah,
yeah,
distributed
ledger. Yeah,
ledger,
yeah.
and yeah, there was one more thing that just skipping my mind, but yeah, I think so. Overall, we're trying to, so basic is the function, hash function. Then you get into like you're gonna use this as the basic block, and I think all the concepts make sense from here on. Then once you know, I think then you know, okay, what is money, or how the money transactions happens in the real world. It's basically a ledger. There's a centralized authority. You want to eliminate that, and then you are jumping into like, okay, decentralized blockchain and how blockchains are connected, and now how anybody who want to add a block needs to pay in computing power, because there's a proof of work which is very intensive mathematics, basically trial and error of running of that SHA function that they are. Yeah. And I think maybe just to kind of circle back to the initial point where we started, like why it is like blockchain is the important thing to talk about now, and why insurance and this big sorry, employment funds and all that are trusting this technology, is because now it has been running for about 12, 14 years, and there has been no hack, and nobody has been able to actually breach into any of those transactions that has happened in the past. And then there is the technology is very good. It's solid that it has been running without any control. Anybody could do it, do anything, but it just didn't break down. Yeah.
Actually, I mean, now obviously, like we are almost up with the time, but this is actually something that we should talk a bit more about, because, like today, what we explored was just the functioning, the fundamentals, a bit of historical kind of origin story. But
Yeah.
the thing is, uh, if we talk about insurance company or retirement funds,
Funds. Yeah.
these are like extremely important, high value money, for example, resource that you're putting up here. I think we should definitely discuss like why such systems are trusting blockchain, because still there are many questions like unanswered.
So all right. So what I meant in the context of why they're trusting, but they are trusting the money of the people that they have in their hand. They are giving it and investing in Bitcoin, and they are investing it in, assuming that as an asset. Uh,
Oh, I see, I see, I
Not
see,
just
I
using,
see.
like definitely there are
Uh-huh.
use cases, But
Oh, okay. Then
what
which means
yeah,
that they're just buying Bitcoin. Okay. I mean
yeah.
that, yeah, that's
But
okay.
if you think about it, for a highly regulated fund to be able to take that leap is a huge thing. That's where that's where the biggest money in the economy lies. Because everybody is paying there, the unemployment funds and all that,
I mean,
or sorry, pension funds and all that. So there's a very huge amount of money that they have. That is what they give to VCs. That is what they give to, let's say, Berkshire Hathaways and on biggest banks. But now they start to tell them, hey, you can use it, you can put it in assets that are running on blockchain, and Bitcoin, which is and like Ethereum, which are more trusted ones. We should hold some of it, to be able to,
but that's like a hedging. I mean,
yeah,
that's
they
just
are they are
hedging the
hedging.
risk. And
But also now it has gone beyond hedging, because this I think it has become like initially it was not even allowed, but I think now
yeah,
they're feeling that, okay, it's secure enough that it won't just go away. That's why I think my first point was like, it's too big to die. Now now there is so much money into, and like all retail investors and small players have built the whole thing, that it's just too big to die. So it will be there, and now it kind of start to make sense. It's not only hedging anymore. There is up to this point there has been no point where you can see, oh, it's the appreciation in Bitcoin prices or anything kind of not does not correlate to S&P 500 or something. So there is a strong correlation. When there is money in the market, you see Bitcoin prices go up. When
so
there's
you're
less
saying
money in the
that it's
market,
less volatile, more predictable, therefore it is an asset just like any other
any other,
investment
yeah,
to
any
make.
other assets, which is a big thing, because if you think about it, this is started by god knows who. This is just maths at the end of the day, of which there is no certain proof, and you are putting people's pension money in there, and it's good. They waited long time, but I think if they are trusting it, that's why it's important topic to talk about. you know that's the most conservative firms out there in terms of investing.
Yeah,
So
yeah.
yeah,
I think it is definitely like worth like talking a bit more, or maybe just reading a bit more, if not basically creating an episode. But we do have now run out of time.
yeah,
So I think this was
that's
definitely a very like a very good, I would say, sharing or kind of like building like, okay, what is this whole thing about?
yeah, I think
And
kind of
it's
exploring together. I
yeah,
think that's how it, to me it is, because
yeah.
there's so much to it. It's just you need to just discuss and explore, and I think this was a very good discussion in that regard. Yeah.
Yeah, yeah, yeah. So great. So with that, I think we close for this weekend and we reconnect next week.
Yeah, and next week we hope our friend Sid can join us, and yeah, I think we will. We have not yet decided on like what we'll talk about next week,
Yeah,
but yeah,
yeah.
I think
We
there
can
definitely
discuss
will.
during the week and come up with a topic.
Yeah, awesome.
Perfect. All right. Let's talk next week.